Assalamualaikum warahmatullahi ta'ala wabarakatuh. Now we continue with the second part for the chapter reaction kinetic. So we continue with the Arrhenius equation. Arrhenius equation is the mathematical relationship between rate constant, the temperature and the activation energy. So this is the equation of the Arrhenius equation. K is equal to the AE to the power of the activation energy over R and temperature, where EA is the activation energy, T is temperature, R is the gas constant, where that we use the 8.314 joule per kilo per mole, and A is the frequency factor. So this Arrhenius equation is very useful because this Arrhenius equation can analyze the effect of temperature on the rate constant, hence the reaction rate, and also it can determine the activation energy for a reaction if the value of the rate constant are known at different temperature. Let's say we use the Arrhenius equation, which is K is equal to the AE to the power of EA over RT. Then you rearrange the Arrhenius equation using the calculus. Then you will get another equation, which is ln K is equal to the ln A minus EA over RT. By using the equation, you plot the graph K versus the temperature, then you will get the graph like this one. Let's say from the graph, you just use 2 point, which is 0.1 and 0.2. From the point, you can get the value of K1 and T1 for 0.1 and K2 and T2 for 4.2. Then using the K1, T1, K2, T2, then you substitute into the equation, then you will get another equation, which is we can get the equation 1, which is refer to the K1 and T1, and equation 2, K2 and T2. Okay, let's say equation 1 minus equation 2, then it will give another equation, which is ln K1 minus ln K2 is equal to the EA over R times with the in the bracket 1 over T2 minus 1 over T1. Then for the ln K1 minus ln K2, we can rewrite into the ln K1 over K2, and then this equation will be used if you compare with two temperature or compare with two rate constant. Then by using the equation ln K is equal to negative EA over R times with 1 over T plus ln A, then you will get the straight line when you plot the K ln K versus 1 over T, the graph like this one. So by using the equation, you can get where the ln K as a y-axis, and then 1 over T as a x-axis, ln A is the C, and then EA, negative EA over R can be obtained from the slope of the graph. This is the example involve the Arrhenius equation. The equation said the activation energy of a certain first order reaction is 75 kJ per mole at 27 degrees Celsius. The rate constant of the reaction is 8.8 per second. So what is the rate constant of the reaction if the temperature is increased to 37 degrees Celsius? This question can be done by using the equation. Okay, this equation. So first step, you need to extract all the information from the equation, which is the EA is equal to 75 kJ per mole, can change it to joule per mole by times with the 1000, and then for T1 is equal to 27 degrees Celsius, change it to the Kelvin, 300, and then when T1 27 degrees Celsius, K1 is equal with 8.8 per second. So what is the K2 when the T1 is equal to 37 degrees Celsius, which is we can change into 310 Kelvin, and then R is equal to 8.31 joule per mole per Kelvin. By using the equation, you just substitute all the value into the equation, okay, like this one. Then just calculate the value of K2, which is K2 is equal to 23.2 per second. So which means when T2 is 37 degrees Celsius, the rate constant is 23.2 per second. Okay, I think that's all for the chapter reaction kinetics. So thank you very much for your attention. So thank you. Bye.